Hello everyone, let's try to be a cheat code ninja today. This problem is a very tricky one because solving it requires two parts and the second one is very difficult to come up with. Let's have a look at it. We are given an integer array nums and for each integer we have to find the second integer which is greater to it. So what it basically means is that our second greater integer should be greater than our original number and there should be exactly one integer in between them which is greater than the original number. If for a number we don't have a second greater integer, in that case we could return -1 for it. You could look at this given array. 2 is greater than 1 and 4 is also greater than 1, but 4 is the second greater integer to the right, hence it is the answer. Similarly for 2, 4 is greater to it and also 3 is greater to it. But 3 is the second greater integer, hence it is the answer. For 4 and 3, there are no second greater integers, hence we return -1 for them. Let's look at the given example. Here 4 is greater than 2, but 9 is the second greater integer for it. Similarly for 4, 9 is greater to it, but 6 is the second greater integer for it. Similarly for 0, 6 is the second greater integer for it. And for 9 and 6, there are no second greater integers. Let's try to think about this problem and come up with a solution. Let's consider this example. Instead of finding the second greater element, let's try to find the next greater element and see how we can use it. For 2, the next greater element would be 4. For 4, it would be 9. And since there are no elements which are greater than 9, it would be -1 for it. For 0, the next greater element would be 6. And since 6 is the last number, the next greater element would be -1. For finding the next greater element or the next smaller element in an array, there's a very efficient data structure called as monotonic stack. The only difference between this and a normal stack is that in a monotonic stack, we keep elements in an increasing or decreasing order. Let's look at it. Since we have to find the next greater element, we'll keep all elements in a descending order. For each element, we'll check if it is greater than the last element. If it is greater, then we'll start popping elements from the end. We'll continue to do this till our current element becomes the smallest element in the stack. This would become apparent after this example. Let's go through all our elements one by one. Since there are no elements in the stack to compare with, we'll push 2 to our stack. Our next element 4 is greater than the last element in the stack. We would now pop it, and our current number 4 would become the next greater element for that number. Our next element 9 is greater than our last element in the stack. Hence we would pop 4, and for 4, 9 is the next greater element. Now there are no more elements in the stack. Hence we would just add 9 to our stack. 0 isn't greater than the last element in the stack. We would directly add it to our stack. You could notice now that our stack is keeping elements in a descending order. 6 is greater than our last element in the stack, hence we would pop it. For 0, 6 would be the next greater element. Since 6 isn't greater than 9, we won't pop it. Now we'll just add 6 to our stack. Now there are no more elements and we could see that there are 2 elements remaining in the stack. For these 2 elements, there are no next greater elements, hence we would keep it as -1 for them. The time complexity of this would be O of n because we are adding each element to the stack only once and removing each element from the stack at most once. And the space complexity would be O of n because we have to keep a stack of size n. So now we have a way to find the next greater element for each element. Let's keep track for which all elements a particular element was the next greater element. 2, 0 and 6 weren't next greater elements for any number. 4 was the next greater element for 2, hence we are storing index 0 corresponding to it. 9 was the next greater element for 4, hence we are storing index 1. Now let's try to find some clues with this. For 2, the next greater element is 4. This also implies that the second greater element would be to the right of 4. Hence, any number to the left of 4 cannot be the second greater element for 2. Similarly, for 4, 9 is the next greater element. Hence, its second greater element can only be to the right of 9. All elements to the left of 9 can never be the second greater element for 4. For the second greater element of 4, we can consider 9 to be the middle point. And any element to the right of 9 which is greater than 4 is the answer. This is the trickiest part of the question. We have to use some data structure which could simplify the comparison of the elements to the right of the pivot with the elements to the left of the pivot. We can try to use a heap because it maintains some level of ordering with respect to the maximum or the minimum. And elements to the right of the pivot can compare with the top of the heap. Since the right elements need to be greater than the elements on the left, it makes sense to use a min heap because we can directly compare if the elements to the right are greater than the minimum of the heap. And if it is greater, then we can pop that element, and for that element, the second greater element would be the element on the right. There's one thing to be careful of. Our pivot element is already a greater element, so we don't want to make any comparisons with it. Hence, we would only add elements to a heap once they have crossed their next greater element. So in this case, their comparison would only be restricted to the potential second greater elements. And whichever is the first number that is greater to it, it would be our second greater element. This can all sound confusing to you, but it will become clearer with an example. Let's note down our condition so that it will be easier for us to track. Let's run through this complete example. First of all, let's create a main heap. For first element 2, the heap is empty, so we'll do nothing with it. We'll only add the elements to the heap once they have crossed the next greater element. Hence, we won't be adding it now. Our next number is 4 and our heap is empty, so we won't be doing anything with it. 4 is the next greater element for 2, so we'll add 2 to our heap. For our next element 9, we'll compare it with the topmost element of the heap and check if it is greater than it. As 9 is greater than 2, we'll pop 2 from our heap and 9 would become the second greater element of 2. Now we'll add all the elements for which 9 is the next greater element. 9 is the next greater element of 4, hence we'll add it to our main heap. For our next element 0, we'll compare it with the top of the heap. We can see that it is not greater than the top element, hence we'd continue. For our last element 6, we'd compare with the top of the heap. As 6 is greater than 4, we'd pop it from a heap. And for 4, we would mark 6 as the second greater element. Now there are no more elements to check. All the elements for whom we could not find the second greater element would store -1. The time complexity of this solution would be, for each element of the array, we may have to push or pop to the heap. A push or a pop operation takes log n time, and since we would have to do it n times for each element, it would take total O of n log n. The space complexity would be O of n because we are using a stack and a queue of size n. Let's implement our solution. Let's rename our variable to a. Let's keep a variable for the length of our array. We have to initialize a 2D array to keep track of all the elements for which that element is the next greater element. We'll call it middle. We also have to initialize an empty stack. Let's loop over the numbers and find the next greater element. We'll check in a while loop if our stack is not empty and the last element in the stack is less than our current element. In that case, our current element would be the next greater element or the middle element or the pivot element. We'll pop that element from our stack and store its index in our middle array corresponding to our current element. We'll now add the index of our current element to the stack. Please note that we are only storing the indices in the stack and not the number themselves. Let's initialize our result array with -1 for all the elements. Let's initialize our min heap. We'll be storing two things in it, the number and the index. We have to again go through all the elements in our array to find the second greater element. For each element, we'll check if the heap is not empty and the top element of the min heap is smaller than our current element. In that case, the second greater element of that top element would be our current element. So we'll pop that element and we'll mark its second greater element or current element. Once we are done comparing for that current element, we'll add all the elements to the heap for which it is the middle element. We'll be pushing the number and its index. Our heap would look something like this. The index would be at the first position. Hence we are writing 1 over here. At the end of this loop, we can return our answer. Let's submit our solution. As you can see, our solution is accepted. If you have doubts or concerns regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel. It would help this channel a lot. Thanks for watching.